Use the derivative formula f prime of a equals limit as h goes to 0 of f of a plus h minus f of a all over h to find the derivative of f of x equals 1 over 5x plus 2, where a equals to negative 2. First thing to do is to write the derivative formula for the a value of negative 2. So that'll be f prime of negative 2 equals the limit as h goes to 0 of f of negative 2 plus h minus f of negative 2, all divided by h. The next thing to do is to evaluate f of negative 2 plus h and f of negative 2. F of negative 2 plus h means to take f of x, 1 over 5x plus 2, and replace every x with a negative 2 plus h in parentheses. That will give us 1 divided by 5 times negative 2 plus h plus 2. And then we're going to subtract from it f of negative 2, which means to replace every x with a negative 2. So 1 over 5 times negative 2 plus 2. This entire thing is over an h. We have the 0 over 0 in determinate form, and we will continue to have that until we can factor an h out of the numerator to cancel with that h in the denominator. We don't have the ability to do that right now. What we do have in the numerator are two fractions that are subtracting each other. We're going to need to combine those through a common denominator. The common denominator would be kind of messy if we were to write it right now, so let's simplify those denominators so that we can make the common denominator a little bit easier. So we have f prime of negative 2 equals the limit as h goes to 0. To simplify them, I'm going to distribute the 5 and combine any like terms. That first fraction will be 1 divided by 5 times negative 2 is negative 10. 5 times an h is a positive 5h, and then we have that plus 2. And we're going to subtract 5 times a negative 2, which is a negative 10, and then plus 2. And all over h. So we have limit as h goes to 0 of the first fraction, 1 over, I have a 5h, and I have a negative 10 and a plus 2 that can combine. So that'll be minus 8. The second fraction, a negative 10 and a positive 2 combined to be a negative 8. So we're actually subtracting a negative 1/8. It might be helpful to, instead of subtracting a negative, write it as adding a positive. Double negative cancels to become a positive in between those. That just will make the common denominator process a little bit easier. So we can now formulate the common denominator. We need to multiply that first fraction by 8 over 8, and that second fraction by 5h minus 8 over 5h minus 8, because the common denominator will be 8 times 5h minus 8. So 1 over 5h minus 8 times 8 over 8 plus 1 over 8 times 5h minus 8 over 5h minus 8. All of this is divided by h. So we have limit as h goes to 0 of, multiplying the numerator, 1 times 8 is an 8, and a 1 times 5h minus 8 is a 5h minus 8. I've already added them together over the common denominator of multiplying the denominators, 8 times 5h minus 8. And then all of this is over h. Now, in the numerator of that fraction, the 8's can cancel. We have a positive 8, we have a negative 8. Our next step is to take the reciprocal of the denominator fraction, so I'd put it over 1, so it's a fraction. We're going to reciprocate and multiply it. So we have limit as h goes to 0, 5h over 8 times 5h minus 8, and then times the reciprocal, which is 1 over h. We actually multiply these. This gives us limit as h goes to 0 of 5h over 8 times h. I'll just put the h between the 8 and the 5h minus 8. What we do now is factor in h out of the numerator if there's multiple terms, but there's only a single term up there, the 5 times the h, and that h that's multiplying in the numerator with the 5 can cancel with the h in the denominator that's multiplying with the other expressions, and that removes the 0 over 0 indeterminate form, which means we now have an expression that we can plug a 0 into the remaining h's. Plugging a 0 in will give us a 5 over 8 times 0 minus 8, which is just negative 8. 8 times 8 is 64. And so I'm getting a 5 over negative 64. The negative can move out front. And we have negative 5 over 64. This will represent f prime of negative 2, which means the derivative of f of x, and then evaluated at an x value of negative 2.